Heterodoxy's critique of the cost curve. Our video on equilibrium introduced the three axioms through which heterodox economists characterize mainstream neoclassical theory. These were 1. Individualism, a presumption that marginal revenues will approach marginal costs because of individuals' selfish wish for maximal profit. 2. Instrumentalism, the putative control of macroeconomic activity through reference to production and utility parameters. And 3. Equilibration, asserted as a mandatory imposition upon the mathematical instability inherent in any mathematical expression of individualism with instrumentalism. Each of these characterizations can be validated by observation, and taken together, they do span the neoclassical oeuvre. Heterodox departures from the mainstream are based on their discoveries that one or more of these axioms is hostile to worthwhile analysis. SF Econ, being essentially neoclassical, justifies its continuation of mundane praxis with resistance to the generic arguments based on each of these axioms. Our video on equilibrium challenged the assertion that no mathematically operative system can express an interaction between individualism and instrumentalism while remaining dynamically stable. To the contrary, any SF Econ demonstration falsifies, by direct counterexample, allegations that neoclassicism cannot tell us anything unless it can reference equilibrium. All of SF Econ's prototypes are motivated to align marginal revenues with marginal costs within boundaries set by production and utility parameters. And any SF Econ prototype operating within constant boundaries can be observed to quickly arrive at the optimal steady state implicit in those boundaries. Yet these models contain no statements about equilibrium. They never compute the optimal state for which they are destined, and when such a state arrives, the model will not recognize it as distinct from any other state. Our video on Foundational Microeconomics addressed heterodoxy's attack on individualism as based on the findings of behavioral economists. The argument here is empirical. Extensive sociological investigations lead us to an inescapable conclusion that individuals and groups of people do not behave in predominantly self-interested ways. And Fritz Machlup went off the Austrian reservation when his researchers forced him to conclude that particular enterprises exhibit no special affinity for operating where marginal revenues equal marginal costs. Having found that the referent phenomena of managerial and microeconomics do not behave in accord with their causal presuppositions, heterodox economists have found it safe to conclude that marginalism is just a pretty piece of mathematics having no reference in exterior reality. Contrary to these findings, SF Econ appropriates what are generally considered as the mathematics of economics microsphere for descriptions of our macroeconomic sectors. The Foundational Economics video challenged heterodoxy's planted axiom that marginalism's failures at the micro level of analysis must indicate its failure to apply at the macro level as well. SF Econ opposes this conclusion with our observation that, while the whole is indubitably the sum of its parts, no whole system has ever behaved in any way resembling the behavior of any of its parts. Thus, macro phenomena are always explained in ways having no resemblance to that which explains the operations of those constituent parts. If heterodoxy has discarded marginalism on the grounds of its failure to explain micro phenomena, then SF Econ should be free to investigate marginalism's power to explain macro phenomena. The potential of this approach is indicated in our video entitled An Empirical Study. This video is intended to reinforce neoclassicism's third support, instrumentalism. Heterodoxy's attack on instrumentalism began when John Maynard Keynes' best-known acolyte, Joan Robinson, launched the post-Keynesian movement with this declaration. For Adam Smith, Ricardo, and Marx, the central subject of discussion was the accumulation of means of production and of property. In a stationary state, there is no accumulation. The neoclassical school, which came into fashion in the second half of the 19th century, introduced two quite distinct ways of eliminating accumulation from models, which were intended in other respects to correspond to reality. One was to consider the situation, so to speak, today, with the physical stocks of commodities and means of production that happen to be in existence. The other was to consider the situation at Kingdom Come, when the process of accumulation had been completed, and no one finds it worthwhile to acquire anything more. Professor Robinson's notion of neoclassical stationary states might be most readily visualized in terms of an SF-econ cost curve. Our presentation of a cost curve begins with an expression of diminishing marginal utility. The figure showing has incremental increases in output y, requiring ever larger expenditures, sigma, for the assets needed to produce the output. A revenue curve can be imposed on this figure by simply erecting a straight line through the origin at a slope equal to the output's price, pi. The definition of a stationary state allows us to presume that everything produced will be sold. Every vertical chord between the cost and revenue curves indicates a rate of profit for a given rate of output y. An economic agent will of course choose to operate at the point xi of greatest profit. The fundamental theory of calculus tells us that xi will occur where the cost curve's tangent equals the revenue line's slope, pi. Post-Keynesianism's finding of neoclassical insufficiency is readily visualized by this diagram. If output and sales are to increase, indicated by xi moving to the right, then the revenue curve must also tilt upward to a greater slope pi in order to express another equilibrium. But we know that this does not happen. Expanded production and sales are almost always observed to result in lower prices. Professor Robinson's complaint is hereby made quite specific. If neoclassicism's cost curve describes her today, then it is inert. Its expression of optimality cannot, by definition, be improved upon, and neither can it be diminished because the profit motive will not allow it. And if neoclassicism's cost curve describes her kingdom come, then it cannot be approached. Because nothing can be adjacent to the optimum, there can be no dynamic for advancing toward it. So far, it must be conceded that the post-Keynesian case is unassailable. But where have our adversaries demonstrated that cost curves must be fixed points of reference? Nothing in neoclassicism requires it. In fact, SF-econ gets along quite well with a functional relation between the optimal output xi to be achieved under a given constraint sigma on expenditures for productive factors. As shown, our cost curve is a complicated function of an agent's utility trade-offs, ZU, and the highly variable price environment, P. This introduces the possibility that a cost curve can become more efficient during the approach to kingdom come. And if this is the case, then familiar neoclassical analysis presents us with an instance of output xi having increased as the output's price pi has decreased. To construct an experiment that might establish this dynamic, we set out an elementary SF-econ model in its optimal state. We then require that one sector's production function suddenly becomes more efficient with respect to all its inputs. Keeping all other boundary conditions constant, the model is released on the dimension of time. When kingdom come arrives, in the form of a new optimal steady state, we see that the more efficient sector has increased its output. Note that this model's causality is the same at every disequilibrium now, up to and including the ultimate equilibrium of kingdom come. The succession of disequilibrium states, leading from that initial to the final optimum, is accomplished by the accumulation and disaccumulation of the sector's means of production. Every sector's cost curve always indicates that increased output requires an increase in price, and yet the model's final state has the more efficient sector producing more output, while delivering it at a lower price than was the case at the experiment's inception. Having set these contradictions in a dynamic modeling context, we can demonstrate that they are resolved in the fullness of time, and having done so, we can proceed with some confidence toward an explanation as to why. Though the efficient sector's cost curve always requires a higher price for expanded output, the shape of that curve will, as the emulation proceeds, change its shape owing to the initial stimulation, as well as to the changing of the sector's factor prices. While the efficient sector's output is expanding from one moment to the next in our emulation, the shape of its cost curve will also change, such that the higher price demanded for the expanded output in the current period will be less than the higher price demanded in the prior period. Eventually, this succession will portray the observed phenomenon of higher output driving down the output's price. In sum, we find heterodoxy's case against mainstream neoclassicism proceeding entirely from its a priori denial of any possibility for a proper mathematical dynamic that renders the closure of marginal revenues with marginal costs. Our sense of proper in dynamic modeling would see no contradictions in the observations that Professor Robinson found intractable. In our understanding of mathematical dynamics, one and the same model should seamlessly represent the economy's instantaneous states, the succession of these states that follow disequilibrating stimuli, and the final state at which such stimuli have been absorbed. To us, these are mundane expectations, and expecting otherwise is what would strike us as peculiar. A dynamic theory of anything is confined to what is happening in a given moment. The reality of time contains no long run, no short run, only a now. All a dynamic machine knows at any point in time is its current state and its rules for getting to its next state, one differential element of time hence.